that you remember when you are doing these kind of questions is that what I suggest my students always is that always take the left hand part as anode and don't change that. So this is your cell. This is your cell. This is the positive part. This is the negative part of a cell. So just keep it like this. Always keep the anode on the left side of the paper and the cathode to be the right side of the paper. So what is, and another thing which I suggest is that so the mnemonic that you can use is red cat. Red cat. Red cat implies okay. Red cat implies that the reduction will always take place at the cathode. Another thing that you can another phrase that you can remember is an ox. An ox. So what does an ox implies? An ox implies that the oxidation will always take place at the anode. So this is a mnemonic that you can remember. An ox. Red cat. So reduction will always take place at the cathode, and at the anode always oxidation will take place. And we already know the mnemonic for oxidation and reduction also. It is oil rig. This is the mnemonic that I prefer. So oxidation is loss of electrons. Reduction is gain of electrons. So the two mnemonics that we'll be using is an ox and uh, an ox, red cat, oil rig. So keep the anode, the positive side of the cell, always on the left-hand side of the paper, and the cathode on the right side of the paper. Then see, these are called the electrodes. These are called the electrodes. The solution which will be there, this is called the electrolyte. Will be taking different kind of conditions. Another thing that you can remember is that the positive ions, they'll be moving like this. They will always be moving in the anti-clockwise direction, and the electrons will be moving in the clockwise direction. One way of remembering this can be that you can assume that electrons are coming like this. They are coming like this from the right hand side. They are going down like this, and the positive ions, they are going like this. See, these are simple ways of visualizing electrolysis. They will help you a lot because at times things get a bit confusing. So always remember that the positive ions will move in the anti-clockwise direction. If we complete the cycle, they will be moving in the anti-clockwise direction, and the negative ions, they'll be moving in the clockwise direction. Remember that. The third and the final thing that you need to understand is that in electrolysis, there is a selective discharge of ions. So what does it mean, selective discharge of ions? So you'll have ions, you'll have cations and anions. You'll have cations and anions, and if you have done electrolysis, you'll understand these cations and anions have to there has to be a discharge of the cations and the anions. So what I'm trying to say is that there's a selective discharge of ions. Now, the selective discharge of ions depends upon the nature of electrodes. Nature of electrode implies that sorry. See, there can be conditions where you are dealing with inert electrodes. Inert electrodes implies that they won't take part in the electrolysis. So they will be electrodes like graphite and platinum usually. So these are the inert electrodes. They don't take part in the discharge. That is not the only case. You can have active electrodes also. Now, these are the electrodes which will actively take part in the electrolysis. So they will have there will be conditions when the one of the both the electrodes would be copper, nickel, silver. So these are the kind of active electrodes that you will see. So the first condition is that there is a selective discharge of ions. It depends upon, first you have to see what is the nature of electrodes that you are dealing with. Second very important thing is the concentration of ions. So for example, I'll give you, or you might be knowing, or I'll give you a small example. For example, for sodium chloride, you can have three conditions. You can have molten NaCl, you can have dilute NaCl, you can have concentrated NaCl. Now, in these are three type of electrolysis that are possible with a single compound. So the kind of discharge which will take place at the electrode would be different. So that is why I'm saying. So the second condition that you will have to see whenever you are doing a question is you'll have to see the concentration of the ions. The what kind of electrolyte is there. We'll see the examples. You'll understand. But here I'm just giving you a brief before I start the main lecture. The third thing would be relative position in electrochemical series. So what this implies is that you'll have as electrolyte in the electrolyte, you will have positive ions, you will have negative ions. So there will be a competition to get discharged. So for example, in sorry, so in anions, which one will get discharged? In cations, which one will get discharged? So that also depends upon the relative position in the electrochemical series. So what this implies is, so for example, you have cations. Now cations, all these metals that you see on the side, they will form cations. So for example, you might have something like Na positive, or you might have something like Cu2 positive. So as you can make out that these cations, they will get attracted to the cathode, that is the negative end of the electrode. So when they are going to discharge, which one will get preference? We'll see examples. So when we have to see which one will get preference, so we need to understand that it depends upon the increasing ease of reduction. So for example, let me take an example. So for example, we have H positive and we have Cu2 positive. So in this, Cu2 positive will be more, will want to get discharged more. There will be an increasing ease of discharge at cathode by gaining electrons. So Cu2 positive would prefer to get two electrons and get discharged at the cathode rather than H positive. So what I'm trying to say here is that it depends upon the discharge of the cations depends upon this series. Then if you see in electrolysis, you will get anions like these. So when you have anions like these, so which will get discharged preferably. So for example, let us say there is a competition between sulfate ion and hydroxide ion. So which will get which will get preference to get discharged easily. Now these, as you can understand, these anions, they will be attracted to the positive electrode. That is, they will be attracted to the anode, the left electrode, and they would like to lose the electrons. For example, between sulfate and hydroxide ion, the hydroxide ion will always want to get discharged easily. And one of the equation that you need to remember is that when hydroxide is discharged, O2 is formed, and this is the equation that you need to remember. I'll repeat. Whenever hydroxide is discharged, oxygen is formed. So hydroxide will get attracted to the positive end, Positive end is anode. At anode, there will be a loss of electron because at anode, we have said an ox. So at anode, oxidation will take place. Oxidation is loss of electrons. When there is a loss of electron, this equation will always be there. So hydroxide will always get discharged using this equation. And remember, whenever hydroxide will get discharged, oxygen will be formed. And if you see hydrogen getting discharged, then hydrogen would be. So the brief is that there are few things in electrolysis that you need to remember before you start attempting the question. So, and when you are doing electrolysis, that selective discharge of ions is selective discharge of ions. Principle of selective discharge of ions is now. After this brief, I'll start with the questions one by one. We'll be going through the questions, and